So if we look at this first one right here, what is the slope of that line? When we look at that, Julia. Good, because this is the number in front of x. So our slope is 16. So think of it as kind of like 16 miles per hour. We don't necessarily know our units, but that's how fast that person is going. It could be miles per hour, could be feet per minute, meters per second. But 16 is how fast we're going. Well, if I go to the next one, what's our slope in the next one, Julia? Good. This here has to be your slope. So we're going 10 miles per hour in that one. So we should know where to find our slope in the equation of a line. The next one, this is your slope, 14 miles per hour. The next one, that 12 is your slope. We're going 12 miles per hour. So the slope is your rate of change. It's telling us how quickly we are moving. That's what slope means when we take it away from just an XY plane. All right. So our fastest was what, Julia? Good. So we're going fastest at 16. Now it's asking what part of the bike ride are they going fastest? So it's really asking in terms of these intervals. We would say during the hour 0 to 1. So in that first hour, that's when he was riding his bike the fastest. All right. And then as we look through these, the 10 obviously is the slowest he was riding, 10 miles per hour. That happened over the second hour between 1 and 2. All right. All right. 2. What is the domain of this function? So the domain, again, is what, Armando, the x's or the y's? Good. The domain is all the x values. So basically, we'll look at what x value does this function start at? What x value does this function end at? Well, that's what all of this over here means. These are the times in which we were riding our bike. So our domain, our x values started at 0. And there was a bunch of different ones. We would start at 0. Let's use that set builder notation so we get used to that. And it continued until what x value, Omar? Good. Until 4. We basically rode our bike for 4 hours. All right. A little different time, rate of change each time, but we started at 0 hours and we finished at 4 hours. All right, number 3. We alluded to this a little bit the day before. If I now want you to find f of 2 and you don't have a graph to use, you have to use this function here. So let's take a second and see if you remember what we did there before we kind of go through this. So number 3 is asking you to find f of 2. So we did a bunch of these yesterday. And what this is really just saying, normally function notation is f of x. So the parentheses, we no longer have an x, we have a 2. So what that means is the x coordinate is 2, and it's asking you for the y value. So how could we do that if this is now all we're given to work with, if you were not given the graph? And see if you remember what we talked about that day. All right. What you hopefully remembered is what we're looking for. Since I'm looking for when x is 2, what is that corresponding y value? All right, f of 2. We have to look at these 4 options. So here's subfunction 1. Here is the second one. Here is the third one. Here is the fourth one. X equals 2. Does that fall in the interval of 0 to 1? No. So we don't want to use this one. So we want to use 16x to find that. Does it fall in the interval of 1 to 2? Yeah. Now notice there's a 2 down here as well. But which one of these has the equal sign underneath it? The second one or the third one? The second one. Here's where x equals a 2. So 2 fits in this interval right here. So what we need to do is take this 2 and plug it in to this function. So we're going to take the x. We're going to replace that x with the value of 2. All right, so I'm going to write this underneath number 3. So 10 times x minus 1. And then what was the y value there? Plus that 16. That's the function for the one that we're concerned about. So now if I want f of 2, all that means we do is let the x become a 2. And then whatever that simplifies to be, that is your y coordinate. So we just go through those steps to simplify this. You would have 10 times a 1 plus a 16. And then hopefully we know 10 times 1 is 10, add 16, and we would get 26. All right. Now, for the first time, and again, you'll have to do this on our quiz when we get to our little test on all of this. I now want you to explain what this really now means. So what we just found is f of 2 is 26. So the point is 2 as the x, 26 as your y. So now kind of think about what all this means. The piecewise function represents the distance traveled. So that's what all of these are. This is the distance that we traveled for each hour in which you rode your bike. So what that would mean now is the 2 is the number of hours we've ridden our bike. So after 2 hours, bad hours there. So after 2 hours, that's what the 2 stands for in our point. So we've just explained the 2, but we also have that 26. What does the 26 mean? If we were to write this out. After 2 hours, we obviously need to add some stuff here. What's happened, Armando? So what has happened after 2 hours? It is in miles. Good. After 2 hours, he said we have biked 26 miles. All right. The function is in miles. That's our distance traveled. The x values are our times. So this is the time it took us to bike 26 miles. All right. Follow that. Okay. If we do, then answer the next question. So if we understood what we just wrote, what Armando just said, then answer number 4, whatever letter that is. Yeah, 4. And then something else we talked about, write that answer in function notation is what I then ask you to do next. All right, so let's see, we got this here. So again, what this stands for right here, all of these y values that we would get by substituting something in, that's going to give us the distance that we rode our bike. All of these over here are the times at which we were riding our bike. So question number 4 was asking you, after 3 hours, so what that's really just telling you is we're going to look for the time of 3. So if I now look at function 1, 2, 3, or 4, Jada, which one of these guys would the x value of 3 fit in? Like, does 3 fit in between 0 and 1? No. Does it fit between 1 and 2? Does it fit between the 2 and the 3? Does it fit in this one? Sort of. We could actually use this one. So see the equal sign right here? So they both have 3s. This one doesn't have the equal sign. This one does. So for this case, we would want to use this 3. That's the hours. and we're just taking 3. You're plugging it in for x in that part of the function. That's what we should have done. Okay, so if we now do that, 14x minus 2 plus 26. All right, that's the function. That's the part of the function we want to use, and we want to figure out what that is after 3. All right, so I just copied that part of the function, substitute in your 3. We get 14 times that 1 plus 26. That then is just 14 plus 26, which is a 40. So now understand what that means. After 3 hours, since that was our time, since it spits out 40, you would have biked 40 miles after 3 hours. Now, I want you to write this using function notation. So that means we want to use the f part of this. Function notation is always f of x. Well, in this case, your x was the 3. So you're going to write f of 3. And then what we found f of 3 to equal is 40. All right, that's how we would write that in function notation. Okay. Okay, last one of just these questions before we graph it. Find the total distance that this person would have ridden on their bike. So how far did this person ride overall? All right, let's see if we're doing this right. Joel, what would we do for this? Good. So what he said for the total distance of 4, why 4? Good. So we just said he rides his bike for 4 hours. So we can see in our time as well, the 4th hour is when we stop. We rode our bike for 4 hours. So what this question is saying, without being quite as just direct, it's really just asking you find f of 4, because that's how long we rode our bike for. So if we look at all these intervals, the only one where 4 is included is the bottom one right here. So we said he's just going to take 4. You're now plugging it into that part of the function. All right, the 12x minus 3 plus 40. All right, and we're going to just let that x be the 4, since that's how long we rode our bike. So this would be 12 times 1 plus that 40. What'd you get, Joe? Good. So he would have ridden his bike a total of 52 miles in that 4-hour period. Okay. All right. So be able to kind of do some of that stuff. If I give you a function, answer some questions on that. And then we definitely want to be able to graph these. So now keep in mind what we have to do. If we're going to graph this, we only need to go from 0 to 4. Those are our times. So this isn't all jammed up. I would not, this graph is huge right now. I would not just go like 1, 2, 3, 4. Otherwise, things are going to be really, really tight in there. So I'm going to skip some in here. Even if we double it, like 1, 2, 3, 4, let's go ahead and, that's probably reasonable. Let's just, every 2, we'll go ahead and label that. So give yourself some room to operate in there. That's going to be our hours. Our x's are the hours we said. And then our y values, just like we do in our table. So the x values are the time. The y values are going to be your distance. So our distance is getting measured in miles. So our y value should get measured in miles. Now, think about how big we need to go here, right? We just found in letter or number 5 that the total distance he rode was 52 miles. So if we try to label all of these a 1, so if we say this is 1, 2, 3, 4, we better make sure we have 52 tick marks. All right, and we don't. So you would have done a lot of this in Math 1, trying to figure out the scale of a graph to make sure everything's going to fit there. So if we count through all of these, what you would find is there are only 25 tick marks here. So we need to change this somehow because we need to be able to get to 52. So what could we go by so that we get pretty close, Assad? Good. 2 is pretty good. That'll get us to 50. We need to get to 52, but since it's just one off, that would be good. So let's go by 2s. So let me erase these guys, hopefully. All right, so we'll do 2, 4, 6, 8, 10, 12, 14, 16, 18. If we do it right, we should get up to 50, and then we'll just have to extend it just a little bit more. All right, then we get to 50. We knew we were supposed to go up to 52, but 52 is easy. We could add one little tick there. All right. Once we have that label, let's start to graph this. So we're just going to do it piece by piece by piece. So if I go back to this first part, I'm just going to graph this guy right here. All right, so the first time we have now done this, understand what this is really saying. F of x equals 16x is the same as saying, so the first one is really just saying y equals 16x. That means at the end, we have a little plus what, since there's nothing there. What's our constant at the end? A 0. So think about this as a slope-intercept form, right? Our slope is 16. Our y-intercept is 0. So if we go to that graph, our slope is 0. I'm sorry, our y-intercept is 0, and our slope is 16. So we're going to go up 16. So now have that labeled. So here's my 16. And then move over to 1, but make sure you go to 1 hour. So we skipped 1. So that should be the first 2 dots. Then I can connect those. This is the beginning of my graph. Now, there's 2 ways we can do this next one. So one way, let's talk about both of them right now. The next one is just this line, 10 times x minus a 1 plus a 16. So we're just going to graph this one here now. I'll highlight this one in blue. I'm just getting this from right here. That's going to go from 1 hour to 2 hours. So there's a couple different routes you could take with this. We could just go to that point, 116 that we just finished at. So here's 116. And then for my new line, count off this slope right here. Go up 10, right 1 from that point. All right, so let's go to that big point there. Go up 10. Now, you're not counting 10 tick marks, so keep that in mind. We want to go up 10 in terms of 16. So up 10 would take me to 26. And then I'm going to go right 1 hour, which brings me over to 2. That would be my next one. Now, the other way we could have done this, didn't we already know what f of 2 was? Wasn't f of 2 26 from number 3? So you could have just plotted that point. Notice where that point ended up. Didn't it end up at 226? Okay, so that's another way we could have done that. So actually, I have to do that one for the next one. Don't we know what f of 3 is already? If you look at your, where are we at here? Number 4, didn't we find f of 3 already? Isn't f of 3 40? So we could just plot that point and then connect them. All right, so go up to 40, add 3. That's my next one. And then we would connect those. If you think about that in terms of slope, we would have gone from 26 to 40. We would have gone up 14, right 1. That just so happened to be our slope as well. Okay. And then the last one, Joe gave us this one. After 4 hours, didn't we drive or ride 52 miles? So if we just plot the point 452, So here's 4. Now you're going to have to add a little bit to the 50 because it would be right about here. Connect those, and then that would be our graph. All right. And then we stop at 4 because that's when the bike ride ended. All right, so be able to do a question like that come on Friday. Here's this little situation, answer a bunch of questions, be able to graph it. Certainly something I'm going to ask you to do here. All right, so next one. Says below is a second continuous piecewise function to represent the average distance traveled in minutes. So again, here is our distance. And then our time is getting measured in minutes. All right, so that's what those mean. Distance traveled in minutes. All right, answer number 7. We just did this on the front page. Write down what that is. All right, domain. What x value does this start at? Omar. Good. And then what x value does it end at? Good. So 0 to 100. This is your domain right here. That's the x values where this function is defined, starting at 0, finishing at 100. All right. You're again going to see this idea of rate of change. So for the third time today, your rate of change is nothing more than your slope. That's what the slope finds us, is how fast we're moving. It's our rate of change, how quickly you're moving. So when this is asking, what is the slope? What is the rate of change from 20 to 50? We should be able to look at this line here and know which part of that is your slope. All right, Monica, what is the slope between 20 and 50? Good. This has to be your slope right there. So that is your average rate of change. All right, that's how quickly we are moving at that time. All right, with that in mind, now number 9, when do we have the greatest, when do you have the greatest rate of change? So write that down. Depending on how good you are with fractions, you may need to punch some of these into your calculator. All right, so our greatest rate of change. Here's our rates of change, right? The slopes, slope, slope. We had 4 slopes. So we're really just comparing 1/4, 1/5, 2/7, and 1/8. That's why you might need a calculator here if you don't know these. Which one of those ends up being the largest? If we were to throw those in. Elk. Good. I don't think so. Not quite. Do 2/7. 2/7 should be bigger than 1/4, I think. What's 2 divided by 7? What is 2/7? Can I write? Okay, there we go. So this is 0.285. This is 0.25. So this is a little bit bigger than 0.25. 0.2, like 0.12, I think. So the 2/7 is the biggest value out of all those slopes. And that's all we're looking for, the biggest slope. If they're not decimals, they're probably easy. But the 2/7 is the largest of all of those. Okay. All right. Answer number 10. See if we're getting this here. Might be the last one we get to. So find the value of each of these. So in the first one, find G of 30. How are we doing that on the front page? So in this one, Lily, if I want G of 30, does 30 fit in that first window here? No. Does it fit in the second one? Yeah. So G of 30 fits in this interval right here, this domain. So we are taking 30 and we are plugging it into this function right here and then just seeing what that spits out. So that's what, 1/5 x minus 20 plus 5. Let me do that up here. So G of 30 should equal the 1/5. Plug in your 30 minus a 20 and then plus your 5. Simplify that. 30 minus 20 is 10. 1/5 of 10 is really just 10 divided by 5. Okay, we reduce that. So 10 divided by 5 is a 2. So what we would get is G of 30 should have been 7. All right. Here's going to be your homework, just so we can kind of get this done, not lose too much more time. You're going to finish these. So 10. So then tomorrow, just have this back page ready to go. That's what I tell you. Check in for the homework. You'll have to graph one. You have to find some values, largely what we've been doing. So just finish that off, okay? And then I'll just kind of check that in as the homework, okay? It's Wednesdays. Kill me a little bit. Yeah. Let me stop recording also real quick.